I/O ports of the microcontroller. We've included two 20-pin connectors, which is directly connected to our switch pad, and that serves as an input to our system. This is our USB port, our audible alert, and we've also included a 6-pin BDM circuit, which allows the user to debug or reprogram the microcontroller. So here's a picture of our working PCB. For future boards, the buzzer over here can be it's kind of big right now, so you could find a smaller buzzer, and you could remove one set of connectors and resistor there. Since this was used for since we have two, one and two, for testing purposes. So we believe the device can be approximately small, 1/3 as small. So the projected cost for our unit is $116.38. But if it is mass produced, the miscellaneous electronic components will not factor in as much. So we believe that the device will be less than $100 as our customer required. For our last slide, we're going to demo. We're going to show a video of our working device. And we actually increased the clock speed of the microcontroller 10 times for demonstration purposes. Okay, so now to start the device, turn on the device, you connect the AA battery. You can't really see it here, but the green LED is blinking every 2 seconds. Now we will apply pressure to our sensing pad, and the red LED will light up to signify that the infant is present. The yellow LED will light up once right there to store the roll time into memory. And now we're going to go pad, and the yellow LED will blink another time right there to store the session into a memory. Now we connect our device to a computer by the USB cable and access our customized GUI. We download data, and you can see the bytes being received. The bytes will be formatted into a .csv file, which can be viewed with like Microsoft Excel or any other spreadsheet. Last but not least, we'd like to thank Professor Wayne, Professor Pisano, Professor Kia, Brian, and Zetel, and the ECE staff for their guidance and advice this semester. We couldn't have made it to ECE day without you guys.
Questions?
So, have you tried it out on a baby? Or a facsimile of the baby?
Okay, well, we were able to obtain a dummy baby that for CPR purposes. So with that, it works, but we're not actually allowed to test with live things for many reasons. But with the dummy baby, yeah, it works. So we mounted it in a car seat, and it was sensitive enough to shoot.
What weight was the dummy?
It was like 3.5 pounds. So actually, it's lighter than our weight requirement, which was 4 pounds. So
Would it squirm around?
the dummy baby not spinning.
No, but what happens to your sister? That was top serious, but seriously, what happens if the baby moves around?
Okay, so that's why we have a wait period of 1 minute before consider as a data session. And then the absolute event has to be waiting 1 minute before it stores the value into EEPROM. So while is like absolute for less than a minute, and it's just gonna the count is gonna start counting. It's gonna wait for this to be correct. This got to the counter again.
So I guess what you're saying is that if there is weight detected on, if there's any pulse during that time, you call the baby there, but if there isn't, you say that it's more than just a squirm that's really been removed.
has to be
Is
moved
that the
forward.
logic of it? No, you just choose English. It's fine. But I mean, is my logic correct? So you're saying is that if it squirms around, that's fine, but if it squirms around so much that you don't detect the signal for a whole minute.
Right, that's
Okay.
correct.
Good, thank you.
Did you try it in a car? Drive around with it, so you get a dummy baby. Awesome.
We were just able to complete the functionality of the project and just test in the car seat by like this day. So I feel like that was
So it's a real just-in-time project.
Yes. And none of us have cars. So. Yes.
Is it water resistant?
That's a definite concern. So I mean, we were able to get the device to function, and obviously, I mean, our black box is packaged so that it would be water resistant but not water proof. So if we submerge our system in water, of course, it would fail. But I mean, it should be able to withstand some water. Our sensing pad, we would have liked to like package some sort of plastic wrap. If we had time, we would have done that. So that would have been cool.
Can you speak about any strain relief so that if it's tugged on by the parents or the baby, what happens to the force on these wires? Do they pull on your circuit board? Or?
Well, I mean, for our switches, they're glued down onto a plastic pad, so they're stuck pretty well. And in terms of the connector, it's connected using just a regular 20-pin Henry cable. So I guess if it was pulled hard enough, it would come off. But the purpose of the device is to like be totally integrated without being visible. So like all the wires would be underneath the lining of the seat, so nothing should be exposed.
It's a major problem with inverter and charging how to deal with it.
I guess there's a lot. Well, I mean, okay. So I guess getting the USB functionality to work was one of the most difficult parts of the project. It took a few months to figure out how to communicate. Because the protocol is really difficult to work with. So luckily, our processor came with built-in library, so that we didn't have to write any code ourselves. We just had to work with it.